All right, we're gonna look at this last section here. Applications of that standard deviation. So, what did I even mean that? Yeah, that's so funny. It says standard deviation. That's supposed to be normal distribution. That's crazy. So, love that. So we want to compare values that maybe are given in different scenarios. So, maybe we want to compare test scores on different tests. So like this first one's going to be like SAT versus ACT. And so we want to know, if we have two students that have only scores from each test, and we want to compare, okay, who might be like the better candidate if we're talking like getting into a certain school, we want to see whose score is better. And it's hard to say based off of just looking at, an ACT score of 23 versus an SAT score of like 1200 or whatever, especially because it's different than from when I took it. Like the ACT is still out of 36, but I know the SAT has changed. But anyway, so let's look at a few examples here. So composite scores on the SAT have a mean of 1060 and a standard deviation of 195. For the ACT, we have a mean of 21 and a standard deviation of 5. So at what percentile would an SAT score of 990 fall? We can do this with technology. We can use Excel or Google Sheets, and I'll give you the code here. We'll put equals, and then we can do normal distribution. So norm dot distribution, and it should pop up. And then it's going to tell you what values to put in. So it's going to say X, and I'll show you in a second. And then it's going to have the mean, standard deviation, and then we're going to want to add in, it says cumulative, we want to say true. So our value is that 990, the mean is 1060, standard deviation is 195, and then we want to put, if I can spell, true. And then it'll give us out a number. So let's go get that number. So I'm going to erase these so that you can see what it's telling us to do. You see that? Say X is for the data value, mean, so 1060. Standard deviation was 195, and then cumulative, we want that to be true. I'll close the parentheses and get a number. So 0.3598, which we can round that to 36. So we can say 36th percentile. All right, that second one. What is the z-score of an ACT score of 27? So remember, z-score is data value minus the mean over standard deviation. So 27 minus the mean, this time it's 21, and then the standard deviation of 5. So let's see, 27 minus 21 is 6. 6 over 5 is 1.2. So now that it's in this standardized score, we could compare it to an SAT score and see which value is further away from the mean in the positive direction. So it's like that third example, actually, we could probably do that. Which is a better score? A score of 1450 or a score of 29? So let's use those z-scores. So for the SAT, that z-score is data value minus the mean over the standard deviation. Let me grab my calculator for that one. So 1450 minus 1060 is 390. And then if I divide that by 195, I get exactly 2. Okay. Now the ACT, let's see, 29 minus 21 over 5. And what is that's going to give 8 over 5, which I believe is 1.6. And so we want the one that has the higher z-score because it's further away from the mean in the positive direction. So it means it's a higher score. And so the higher one is this 2. So the SAT score is a better score. Better because higher z-score. Okay. All right, let's look at coin flipping. So, let's say we flip a coin 64 times, and then we're counting the number of heads. So what would the mean of the corresponding distribution be? Okay, well, maybe I should read this part first. So, we've got number of heads, and we're flipping a coin 100 times. It's normally distributed. It can be shown that if n is the number of coin flips, then the mean is n over 2. I'm going to write that over here. Mean is n over 2. And the standard deviation is the square root of n over 2, as long as n is at least 20. So for 100 flips, the mean would be 50. Standard deviation is 5. Okay. So for us, n is 64, which means the mean would be 64 over 2, which is 32. And then the standard deviation is square root of 64 over 2, which is what? 8 over 2, which is 4. So what would the mean be? It's going to be 32. That's 64 over 2 to give 32. And then what's the standard deviation? All right, I just found that as well. So square root of 64 over 2, which is 8 over 2, which is 4. Suppose we got 25 heads, which seems a little low. At what percentile would 25 fall? Okay, we can use that normal distribution function again. Normal distribution. Our data value is 25. Our mean was what, 32, standard deviation of 4, and then we want true. So let's go into Sheets and get that percentile. I'm just going to go in a new cell here. Equals. And where's my, there we go. So where's my keyboard? Norm. Distribute. And then what was it? It was data value is 25, mean of 32, standard deviation of 4, and true. I wonder, does it matter if it's capitalized? We'll find out. So we get 0.0400. So we'll turn that back into like a percentage type thing. 4. So in the 4th percentile. 4th percentile. I think that is all for that problem. Okay, and then we want to probably analyze the data, right? So maybe let's look at some pictures and analyze it. Okay. The normal distribution, remember, kind of looks like a bell shape. It's pretty symmetrical. So when it looks almost normal, we can pretty much assume that it is normal and use some analysis based off of that, right? So this looks pretty normal because it has that bell shape here. Okay, so to be able to answer all of these questions, we're going to be using technology, and I need all the answers, right? This is just a frequency of these, so I don't know the exact numbers for all of these. So I need to get this actual data here. So I'll pull it up from the textbook, and if you're watching this and you need it as well, I'm going to link it next to this video. So that way you have it as well, so that we can get all of these answers. Okay, when I open the link, this is what it pops up in. It has chapter 8 data sets, and I want the one that's average SAT, right? So what we're gonna do, that first question was, what's the mean of it? So we can take, oh, I should have done this on a computer, not my tablet, because this is gonna have a lot of values here. Goodness. You know what? It does say view only. So I need to figure out how to edit it. And I think it was on that first one. How to copy. Make a copy. All right, let me go do that. Okay, I believe a copy has been made now. So if I go all the way down to the bottom here, I am going to want, well, I can go here and say average. Maybe. There we go. Average. And then I want to tell it what values to do. So I'm in C. So I want from C2 all the way to, looks like C1299. And then I can get the average. So the average score, or the mean, is 1141.174. All right. I want to keep going back and forth, so I'm going to leave it here. So the next question says, using the standard deviation function, like what is the standard deviation? So I'm going to type here and say mean. And this next one, we'll do the standard deviation. So equals, whoops. Why is there still a, okay. Standard deviation of that same data set. So C2 all the way to C1299. Oh, it didn't like that. Try again. There we go. So standard deviation of 125.517. And then the third question, using the answers to the previous two questions, use the normal distribution to estimate what percentile the University of Buffalo in New York falls. So it says average is 1250. I guess so we don't have to go through and find that school. So we want for this one percentile, if I can spell. So we want to use equals and then normal distribute data value, which was what? 1250. And then we just found the mean and standard deviation. So how about 1141.174? Now I know these are SAT scores, so we will have like a whole number. We won't have decimals. But the more decimals we use in this type of calculation, the better our final answer will be. So that's why I'm gonna leave it as these decimals for the mean and standard deviation, and not round it to whole numbers. This standard deviation of 125.517, and I guess I could use the whole decimal it gave me, but and then true. And then it'll give me the rank. So 80.7, so about 81, the 81st percentile. And then it says using percent rank to find the actual percentile for it. See how close the estimate was. Okay. So I'm going to put percent rank here equals percent rank. And then it'll say data, value, and significant digits. All the way to C1299. And the value we were looking at was what, 1250? So we get pretty close, right? So that looks like to be 84. So 81 versus 84, pretty close with those estimates. So that's pretty cool. All right, I'm gonna go back and now write all of these on the actual notes sheet. Oh no, all of my stuff is gone. What the heck? No. Okay. So that mean was, I'm going to pause this so you don't have to listen to it, because I think this is it. Yeah, that is it for the notes. So I'm going to hit pause, and then all this data will be up here for you. All right, so here's it all written for you. And if you have any questions, let me know.